Okay, so I'm going to go through some of these with you, and then after that you can either just grab a textbook or look on your cell phone to find out some of these answers. So we will start with number 2, identify and define the 2 major types of chemical bonding. So we are going to talk about ionic and covalent bonding. Ionic is between a metal and a nonmetal. Okay, so that's also the same thing as something like the metal's positive, so just don't forget that. That's one way I remember ionic. It's the positive and the negative coming together, or being taken, because ionic's not sharing. It's transferring electrons. I'll probably write that too. And then covalent bond is a nonmetal and a nonmetal. So that's a negative and a negative. So they share. Okay, if we look at number 3, it says circle the covalent bond and underline the ionic bond. An ionic bond is a metal and a nonmetal, or positive plus a negative. In this picture right here, you see an anion and a cation. The cation saying metal and an anion being the nonmetal. So what kind of bond is it this if it's a metal and a nonmetal? Right. In the directions it says circle the ionic. No, circle the covalent, underline the ionic. So this would be covalent. If we look at number 4, what is electronegativity? Okay, electronegativity is going to be the affinity of an electron. Affinity also means like your love for something, okay? That's why I put the heart there. The affinity of an electron. In some way you can see that as like your strength or your power to pull another electron, okay? If you have a very high electronegativity, you're very, very strong and you can just rip electrons from other atoms. You don't have to share, okay? But if you have a weak electronegativity, you're going to have to end up sharing because you're not strong enough to take the electrons away. So those are usually covalent bonds, the ones where you share. So number 5, what is the relationship between electronegativity and the ionic character? So the ionic, are they sharing? No, ionic bonds, they don't share. They steal or transfer the electrons. So do you think their electronegativity has to be high or low? High. Because they're stealing. They're so strong. You know, they have an affinity for electrons so high that they're able to take others' electrons. So in your own words, write that on number 5. The relationship of electronegativity and ionic bonds. So I put ionic bonds have a high electronegativity, strong enough to steal other electrons. Because in the ionic bonds, they are not sharing, okay? That's not covalent. Ionic, they literally take or transfer electrons that they get from other atoms. Number 8. Where do you think, it says describe the general location of the electrons in a covalent bond. Where do you think the electrons are in covalent bonds? Like when they get with another atom. So imagine two atoms. Let's just say, let's do, okay. So they share, it's not a very good picture. Okay, but for covalent, if they're sharing electrons, their electrons more than likely are in the middle, in between them. Okay, you can't share something if it's on opposite sides. So the general locations for the electrons in a covalent bond, I would put the electrons are between the two atoms. So if it's a covalent bond, there's sharing going on. So the electrons are going to be between the two atoms. We're going to go to number 10. It says describe the octet rule in terms of noble gas configurations and potential energy. We'll just go ahead and describe the octet rule. And the octet rule is every element wants their outer shell to have 8 electrons. And then I'm writing the outer shell is called a valence shell. So essentially, what they want that's what they want. They want their outer shell, their valence shell, to have electrons. So this would be considered a noble gas. Once you get those 8 electrons in your outer shell, okay, you're considered to be inert. You're not going to react unless there's something like heat applied and you're forced to react. But generally, after you have your 8 electrons in your outer shell, you're very happy. So number 11, determine the number of valence electrons. At this point, you guys know how to find your valence electrons. I'm going to leave those for you. We're going to flip the page. We will start at number 15. It says, what is an ionic compound? A metal plus a nonmetal. Remember, that's positive and this is negative. What are the components of CaF2? So what makes up CaF2? It would be 1 Ca and 2 Fs. Because the 2 is connected to the F, and that's why there's 2 F's. We're not to 17 yet. Okay, I'm going to stop there, and you guys can grab a textbook and help each other out for the rest.